basically the meter is governed by flow rates. You got low flows, high flows, and there are standards that are governing it. You are trying to get the meter to work as much as possible in its nominal flow rates, so that the accuracy is higher and lower percentage of error. This meter was working 76% at the starting flow rate, which is not normal. What is your assumption? This meter is oversized. So if you undersize it, this will go around here. So that's just an example of what MDM can do with data analytics, DIS, Data Intelligence Service. So these are real projects that we were involved in. Confidentiality, I'm not going to mention any water utility names here. But in this case, we actually reduced their apparent losses by almost 4%. This contract was done over 3 years. Then they actually achieved additional invoicing of 5 million. These are all documented facts, and this one also, 6 million over 8 years. The additional invoicing is 2.5. And the reduction was actually higher in this case because it was mainly big consumers. So you can see it went from 43 to 34%. So smart metering opens the eyes. You can see over here, there's nothing going on. You can't really see anything, what's happening. But all of a sudden, you start seeing, okay, these meters are okay, but then you've got 3 that are blocked. You have 3 out of range, 4 that have leakage, backflow, peak flow, oversized, undersized. Thank you.
So thank you, Mr. Imad Dahle, for your presentation. Now we will open the floor for discussion. I would like to ask you, please, from each person to present himself or herself and to specify for whom your question is addressed.
Good morning, Rami Wahbi from Lebanon. My question is to Mr. Al-Shafi'i. Mr. Shafi'i mentioned that in 2010 the non-revenue water was 20% and you're still aiming at reducing it, but I don't remember you mentioned what's the latest non-revenue water percentage that you have measured. It would be very helpful and encouraging also for us to know if it has been reduced further. Thank you.
Yeah, the current non-revenue water percentage for the whole utilities is now is around the range of 25, 26, and we are around that range right now, and it's steady. It's becoming steady. In terms of liters per connection per day, we reached 400, and now we are 480. Because, like Mr. Karalambo said, if you don't do enough, it will rise up again. And also, there are different factors, but you know, from people's behavior, the political situation, but mainly it's that you when you do something, you have to continue.
Kamal Isa, Palestinian Water Authority. Again to Mr. Muhammad Shafi'i. You said 20% non-revenue of water, but it is the total non-revenue real losses and the apparent losses, or this the real losses? It was not clear in this, please.
20% is total. Total losses is 20%. And again, percentage means very little. Right now, we have a rough assessment based on some measurements, which is 50% of the non-revenue water is metering errors, 25% is illegal use, and 25% is leakage.
Good morning. My name is Taha from Yemen, a PhD researcher in Delft University. I have a comment to Mr. Peter's presentation about. I do agree that water audit or water assessment or non-revenue water assessment is not a one-end action. It is a continuous process. And here in the Arab world, I think, and in many other developing countries, the challenge is conducting minimum night flow analysis. There are so many technical difficulties associated with conducting minimum night flow analysis. You know that minimum night flow analysis is mainly designed to continuous supply, and here is intermittent supply. But you can find a solution, and if you fill all the tanks, you can then implement minimum night flow analysis. But still, there are many other difficulties, technical difficulties, such as, in some countries, they cannot ensure that all the tanks are completely full, or maybe the well capacity or the pump capacity, and so etc. So, systematic approach for assessment of non-revenue water is very difficult in developing countries in general, and here in the Arab world in particular. I mean, if you see in Jordan, in the Arab world, you can find only 3 to 4 water balances through all the utilities in the Arab world. This is the main difficulties. And then comes what Mr. Al-Shafi'i says, if you do not know where are your losses exactly, you cannot make an action. So the problem is the assessment, the regular assessment. Is there any other way to assess water losses? This is the question for you and for Mr. Al-Shafi'i. How did you identify the administrative losses and water and real losses through which, and is it a regular basis? Could it be a monthly regular basis or a quarterly regular basis? And another question for Mr. Ahmad, Engineer Ahmad, the energy source of this smart meters. Is it the battery? How long is the life of the battery? Thank you.
I think we should get answer. Yes. The first question was addressed to us.
Thank you for your comment. I think it's a very good comment. And I would agree with you that certainly, we need to take it case by case. I was presenting cases from the Czech Republic where we have 24/7 supply, and therefore some of the techniques and approaches I illustrated, they wouldn't be valid in intermittent water supply systems. And certainly, minimum night flow monitoring is a typical thing which you do when you have 24/7 supply. We have good working experience from other countries where the supply conditions are intermittent, such as from South Africa, Bangladesh, India, and in those, or Nepal, in those countries, you need to adopt the techniques that you are using. And if there is no water in the pipelines most of the day, you cannot do minimum night flows. You need to do other techniques. But I agree with your comment in general that it's more complex than that, and you would always need to work in the conditions that that correspond to the situation that you deal with.
For part of the question, yes, you can do this continually, but you have to do this continually so you can. You have to actually know that you're gonna do it. Technically, you can, but are you going to do it? That's the question. We can talk about the technical. Everything can be solved, and you can start small, and you start by small pilot areas, and you can do it in intermittent or continuous supply. But you have to continue doing it for the other areas as well, before and after, and then again.
So you
For us, yes. But for intermittent supply, there are different methods that we are using. We have contracts in other places.
Sorry, may I suggest that you continue the discussion maybe in the coffee break, because we have questions. Okay.
Do what? Okay. I'm Amal from Palestine. My question to all of you, our speaker, that we know that non-revenue water to reduce is very costly. So in your experience, what is the quick win solution to reduce non-revenue water? As you know, in our country, it is the water utility don't have all this budget. If you don't have the fund, you can't make a big project, a big investment. So what is your quick win solution for reducing non-revenue water?
No, it's okay. Thank you. Thank you for your question. It's a very good question, and it's starting, from my comments that I wanted to make. Now, quick solutions which are not costly. Now, I will go a step back and start from what I think is the beginning. Now, we refer to percentages. Now, I have to say, percentage, Muhammad did point it out, it's not a good indicator for your losses. It's an indicator for the overall performance of the utility in terms of a simple financial analysis. In other words, 100 cubic meters of water enter my network. For 30 of those cubic meters, 30%, I do not get revenue for. So that's the only reasonable indication that one can have. And it's easy, however, and we see that politicians, accountants, even we technical people, we use this to give an indication. But it's not a proper indication of how well a system does. And I think Mohammed in his presentation showed that percentages are not is not a good indicator. Now, where to start? The starting point, and I'm coming to answering the question, the starting point is a water balance. You have to have a proper water balance, which is a starting point of knowing where your losses are in terms of your non-revenue water. Why? Because non-revenue water, as we've seen in the presentations, it's made up of three constituent elements. One is legitimate water, which is non-billed. In other words, we know it's non-revenue, but it's a small amount. And then we have the two big constituent components, physical and commercial, or real and apparent. Now, in terms of volume, they may have the same meaning. In terms of cost, however, the meaning is different. When you put cost to the volumes, you put a different value on the apparent losses because it's water which is being delivered, is taken by the customers. So the cost to that water is your average tariff. And for the real losses, it's the marginal cost of water. In other words, if this water was not lost, I wouldn't produce it. So how much does it cost me to produce that water? Therefore, you convert these volumes into value, into cost, and then you see where is more profitable to go and to reduce losses. Now, you're going to tell me, well, I don't have all this wealth of information and to go and do these things. I want some quick actions so that I can save things. I will just give a few actions that can be taken in either case, commercial and real. Let's go to real. The first thing, stop overflows from reservoirs. Stop leaking reservoirs. Any visual leak that you see, you fix. You don't allow it to run. So these are quick things that you can do in order to improve your leakage. on the apparent losses, make sure that each customer is metered. Make sure that your meters work. That you don't have stopped meters. Make sure that when the meter readers go out, they don't give you false readings. Make sure that the transfer of information is correct. So these are quick things that you can do and you can check on a daily basis, if you like, in order to minimize the non-revenue water. You don't need any additional money for this. The same people that you have in the utility, with a little bit of capacity building, a little bit of awareness of what they can do, they can help the utility reduce the non-revenue water to a level where they can start then understanding that they have to do more. So these are kind of actions, but the next level, it has to be done on a financial gain basis. You will not start doing something that you know it will not give you the best return on your investment. Thank you.
Okay, I think we take one last question.
بسم الله الرحمن الرحيم. صلاح شيخة بلدية نابلس فلسطين. سؤال موجه للسيد عماد. It happened that according to Mr. Imad that some people tried to reverse the direction of water meter. In this case, do your smart meter can be equipped with non-return valve to avoid fraud as well as to poisoning or contamination due to backflow? Thank you.
Actually, as part of the standard, and today, every meter is equipped with a non-return valve. It's not about the non-return valve. It's about the actual removing of the meter and reversing it. Does that make sense? Yeah, but then yeah, but some people can remove the non-return valve because it's just a piece of plastic. It's an accessory. But how would you know until you actually go visit it? Does that make sense? So these accessories are not really governed by the standard, but then they are there. Okay?
Okay, so I think with this we come to the end of this 18th session of the Arab Water Week. Okay, so we take the last question then. Yeah, it's okay, it's okay. We take the last question. Sure.
Hani Al-Koli from Sana'a Water and Sanitation Local Corporation. My question to Mr. Imad, it's actually repeated about the interesting question of Engineer Taha about the energy of smart meters. Yeah, the energy which is using in working in that meters. Yeah, and also like I am from your experience in Gulf countries, I'm interested about the payback period in Gulf countries for your product, like that, the average payback period from like.
Your questions are all revolving around the meter. The meter today is a commodity. That what's important to know is what do you really need? Because there's different technologies, there's different types of, So, yes, of course. The issue is here is it's not about the technology of the meter. It's about what's in your network. So it might be that you get the state-of-the-art meter with the highest, battery lifetime, whatever it is, but it's too much for you. Or it could be the opposite. Yeah. Correct. It depends on what you have. It's all about what's in. See, that's why it's important to know first what you have in your network before you procure any type of technology of meter. It could be wrong. It could not be appropriate. So, but today the lifetime of the things with water, it's not like electricity meters. Electricity meters, they get their power from well, the communication system from the electricity meter itself. So it could be that you can, you know, acquire data every second if you want. It will not affect anything like that. But then the modules on the meters, whether if it's mechanical or electronic, it averages anywhere between 10 to 15 years. That's what the current market conditions are. Or, yeah, well, in Gulf condition, whatever it is, it's just currently what is being offered today in the market is anywhere between 10 to 15 years. Okay?
Okay, so I thank the 4 speakers for the interesting presentations for this session, and I thank you, the participants, for your attention and the interesting discussion that we had today. Thank you all.